All right, everybody. We're doing U-Substitution today. We're just going to start on it, and we'll finish it tomorrow. But up to this point, you've been solving integrals that look something like this. X squared dx. It's a single function inside the integral sign. We can just use power rule here. We add 1 to the exponent, divide by the new exponent, tack on a plus 3, and we're done. That's what we've been solving up until now. Or even, if you want, we can do sine of x dx. The antiderivative of sine is negative cosine x plus c. Very straightforward functions. The next level is when you have composite functions. So if you remember what a composite function is, it's a combination of functions inside of one another. So we're going to look at this here. X squared plus 1 to the power of 3 times 2x dx. Okay, when you get a function that looks like this, you're going to use what's called U-substitution. And JM was talking about this today. How do you know when to use U-substitution? What you can do is two things. And the more you do these questions, you'll get really good at. You'll just know what to do. But initially, whatever's in brackets here, this stuff, that 99% of the time is going to be what U is going to represent. So we go U is equal to what's in brackets, x squared plus 1. Then you do the derivative of the U, of this bit over here. So I go du over dx, and you're going to want to write it that way, is the derivative of x squared with respect to x is 2x, and the derivative of 1, a constant, is 0. The dx then gets multiplied up to the other side, so you end up with du is equal to 2x dx. Hopefully you can see this bit is right there. We already said that u was equal to x squared plus 1 in here. So this integral now becomes the integral, not x squared plus 1, but u to the power of 3. And the 2x dx becomes du. So now we are integrating u cubed to the power of 3 du. Well, that is similar to that function. We just use power rule. That gives us u to the 4 over 4 plus c. And then you sub back in what u was, x squared plus 1. So I get x squared plus 1 to the power of 4 over 4 plus c, and you are done. The whole point of this is to simplify the integral. So what you want to do as a quick check, or a quick, before you do the integral, do your U-substitution, is look inside the brackets. It's either going to be brackets or square root or something like that. Look inside there. 99% of the time, that is your derivative, or what u is going to be. And if the derivative of what's in there, in this case, quickly in your head, you can go x squared plus 1. The derivative of that is 2x. If it's sitting on the outside, that is your substitution. Okay? So let's try another one. It's going to be a short video because I want you to practice these basic ones. Let's do x squared 6 minus x to the power of 3 to the, we'll say 4th, doesn't really matter. And variable of integration dx. Okay. So, and look at this. Look inside the brackets. Boom. What's the derivative of the inside there? It's negative x squared. I don't care about the negative because that's a constant. All I care about is this exponent, 3, is going to go down by 1 and give me a power of 2. Okay? So my u, my substitution, u is going to be what's inside the brackets. 6 minus x cubed. Take the derivative of it with respect to x. Whoops. Derivative of 6 is 0. Derivative of negative x cubed is negative 3x squared. Multiply the dx up. Now you can see this bit is that. However, we don't want the -3 there, so I'm going to pull that to the other side. So I'm going to divide off the -3. So now x squared dx is equal to du over 3. So this integral now becomes the integral, not 6 minus x cubed, it's u to the power 4, and x squared dx becomes du over 3, over -3. All right. We can pull constants out. So I'm pulling the -1/3 out of the integral. So I get the integral of u to the 4 du. That's a power rule. U to the 5 over 5 plus c. I can combine those denominators and I get -u to the 5th over 15 plus c. Then again, we have to sub back in what u was, 6 minus x cubed. So I get negative bracket 6 minus x to the power of 3 all to the power of 5 over 15 plus c. Okay. Let's try another one. Let's do one with the square root. So the integral of x root 3 minus 6x to the 4th dx. Okay, oh, not x to the 4th, sorry. X squared. There we go. So again, look what's inside the root. 6 minus x squared. If I take the derivative of that, I'm going to get -12x. The key thing here is the squared is going to go down by 1. It's always going to be 1 less on the outside for the most basic ones. We will get to the more complicated ones later on. But as soon as you see a power decrease by 1, you know that that has to be u. So u is equal to 3 minus 6x squared. Take the derivative. 3 goes away. I get -12x. I just want x. Okay, so I'm going to multiply the dx up and divide off the -12. So I get du over -12 is equal to x dx. Okay, so that x dx is there and there. The square root becomes integral u square root of u. X dx is du over -12. Pull the 1 over 12 out. -1 over 12, sorry. We don't want square roots, so we write it as the power of a half. We know how to do that. I add 1 to it. That gives me 3 over 2. Divide by 3 over 2, which is the same as multiplying by 2 over 3. Tack on a plus c. Now we got to clean this all up. 2 over 12 is 6. 6, that gives me -1 over 18. U to the 3 halves plus c. I don't want u in there. I want what my substitution was. 3 minus 6x squared to the power of 3 over 2 plus c. That is the antiderivative. And of course, for all of these, if you want to check your answer, you have to take the derivative of this, and you should get back to the original, or this, and get back to the original. And just check it by doing the derivative. These will all require chain rule because you have a composite function. But you can always check your work. All right, one more. Okay, let's do integral 5 cos let's not do 5. Let's do just cos of 5x dx. Okay. Now, I know some people are going to want to say sine 5x. That is not true, because if I asked you to take the derivative of sine 5x, or sorry, not the integral, the derivative, and you were doing that, you go, okay, the derivative of sine is cosine, so I get cos 5x, but you have to multiply by the inside derivative, which is 5. All right? So we have to use U-substitution because the inside here is not x. If it's just x, you can just say it's cos x. But because it's not x, you have to do a substitution. So again, when we up here, we made our u what was inside of the outside function, in this case, the square root. The inside function is inside of cosine. So I go u is equal to 5x. Du is equal to du over dx is equal to 5. Multiply the dx up. Now, we have a dx, but we don't have a 5 anywhere. We've already subbed that out. So I'm going to divide off the 5. And I get that. So now this integral becomes integral cosine. This we said was u. And dx becomes du over 5. I'm going to pull the 1/5 out. Now this, because what's in there is just a linear function, x or u or whatever, it's not to a power, it doesn't have a constant in front of it, I can just do the antiderivative of cosine, which is sine. So I get 1/5 sine of u. I guess plus c. We said u was 5x, so it's 1/5 sine of 5x plus c. I think that is it for today. Let's do one more, actually. No, we'll stop there. Page 301, I strongly, strongly, strongly encourage you to do these questions, 5 to 25 odd, because these are the base ones, and then we start to increase the complexity from here. So knowing how to do the base ones is super important. All right, I'll see you tomorrow in class. Bye-bye.